guys, welcome to Amazing Engineering. Today in this OpenFOAM tutorial I will show you how to set a turbulent case using a LESS model. As first we have to say that unlike RANS model, LESS model can only be used for transient solvers like piece of foam, pimple foam or something else, and for this reason I will use the von Karman case set in a previous video. I will leave you the video in the description in order to create the mesh and the domain, and in this video I will show you all the differences between about boundary conditions for the two cases. As first, let's take a look to the turbulence properties for the RANS case. As you can see, we have only to set the type of RANS model to use, while in LESS model we have to set the type of LESS model to use and the parameters used in this model. One of the best LESS model is the so-called DES model made by Spallart and Almaras, which uses the RANS technique to analyze the small eddies inside the boundary layer and the LESS technique to analyze the bigger eddies outside the boundary layer. We have to set some parameters for the model, for example delta, references length of the cells used in the case, the Prandtl coefficient and the Van der Waals coefficient used in Van der Waals equation to calculate the velocity near the wall. About the boundary condition, there are no differences between velocity file and pressure files in the two cases. So, for example, in velocity file we have for both cases a fixed value boundary condition for the inlet, empty for from back, outlet for zero gradient, symmetry for up and down, and no slip for the cylinder. We had the same boundary condition for the pressure file, so zero gradient for the inlet, empty for from back, fixed value for the outlet, symmetry for up and down, and zero gradient for the cylinder. It's the same for the NUT file. So a calculated boundary condition for inlet and outlet, empty for from back, symmetry for up and down, and NUT wall function for the cylinder. Why the only difference between the two K files is the wall boundary condition, while in RAS model case we use a K-wall function. For a LESS model we had to set as a wall boundary condition a fixed value to 0. At the end, in LESS model we can find another file, the NUTilda file, which is a file used to calculate the eddy viscosity of the case. So we can set a fixed value for the inlet outlet boundary condition for the outlet, symmetry for up and down, empty for from back, and a fixed value to 0 as a wall boundary condition for the cylinder. We can also set the same parameters for the simulation for the two cases. So we can set 0 as start time and 10 as end time, and remember that while every time you are using a transient solver you have to set a very little time step. We set 0 as a number of purge write directories, so we will have a series of purge write directories during the simulation, and after the simulation finished, we can open ParaView with the paraFOAM command. So if we start the simulation inside the RAS model case, we will have this result, while if we start the simulation inside the less model case, we will have another result. In fact, less model, unlike runs model, should give you a better result as simulation, but the only bad aspect about this model is that it can be used only for function solver, so it will take you a very long time to end the simulation. So if you have to analyze a case or a phenomenon for a very long time and you don't take care about the quality of the result, you can use simply a runs model. So you can use a steady state or a transient solver, while if you pay a great attention to the quality of the result, I suggest you to use a last model, even though it will take you a very long time. Okay guys, this is all for today. I invite you to subscribe on my channel and see you for the next video.